Hi everyone, my name is Ritvik. I'm an alumni of American Heritage Palm Beach, and to contribute to the initiative started by the student delegates last year and continuing on this year, I decided I'd solve some of the delegate individuals which were not provided solutions initially. So you can see we're going to be doing the Theta individual from 2021. So I think I'll do the first 10 questions or so in this video, and I'll progress on forward. So I don't have the questions written here, obviously, so I'm going to be looking off to the side to see the question. So if you can pull it up on your own computer with the FAMAT Delegates website. So the first question asks us to find f of 2, and they give us this polynomial. So we're starting off with the easy one here, and we're told that the polynomial is x cubed minus 7x squared plus 16x minus 2034. So 2 is a relatively small number, so you can just directly substitute. We don't have to have any clever simplifications here. It was just resulting in 2 cubed minus 7 times 2 squared plus 16 times 2 minus 2034. This gives us 8 minus 28 plus 32 minus 2034. We can double check that really quickly. 28 is 2 squared is 4, 7 times 4 is 28. 16 times 2 is 32, and negative 2034. This is negative 20. This is positive 32. This is negative 2034. This results in, we can add these two together. Negative 20 plus 32 is positive 12. Minus our resultant negative 2034, which gives us a final answer of negative 2022, which is the correct answer. Or C. Okay, so the second question gives us a system of two equations and asks us to solve for a variable. If you are unfamiliar with the system, just a little tidbit in physics, this is the system set up for an Atwood machine or a pulley system with two masses on either side. And this demonstrates the acceleration of the system as a whole. So, of course, you don't need to know the physics for this particularly, but it'd be nice to know the context for what these variables mean. And the question asks us to solve for A. Now notice here that we're told to solve it in terms of M1, M2, and G, and there is no T here. So therefore, we need to eliminate T somehow. First thing we can do here is notice that, okay, both the T's are positive, which means I have to subtract one from the other. To keep it convenient, I wouldn't like the negative sign here just in case I make a mistake, so I'm going to subtract the second one from the first one. So doing so, we get T minus T, which is still 0. This leaves us with negative M1G on the top. Negative and negative is positive. This gives us positive M2G. And then this gives us M1A, and then negative negative is positive, which gives us M2A. Of course, this 0 is irrelevant to the further of the calculation. We can factor out A here initially, which results in A times M1 plus M2, which is M2 minus M1 times G, which therefore results in A being M2 minus M1 G all over M1 plus M2, which is directly answer choice A. Now, for the further of you fans who would understand the intuition behind this, we can see that G is in terms of a gravitational acceleration, which means it's in units meters per second squared. And M2 and M1 are both dimensionless units or in masses, so the units will cancel out. Thus, we're left with some constant or proportion of G. So the units do check out. Question 3 gives us a polynomial in the form of L of t, which represents the length of Corbin's hair. This is 1 all over t squared minus 34t plus 290. We are then told that T can span across the number of years, and we're asked to find the maximum length of Corbin's hair. Now, the phrasing here is very important. Since we're told that this is the maximum length of Corbin's hair, we want to minimize the numerator, or the denominator, alternatively, because the smaller the denominator gets, the bigger the overall fraction becomes. Now, this holds true, and we can see why this makes sense, because this is a parabola with a leading coefficient that is positive, which means that it faces downwards, which means that it obtains a global minimum, meaning that all we need to do is find the vertex and substitute that value of t. Using the formula negative b over 2a, we can determine that this is negative of negative 34 all over 2 times 1, which gives us 17. Now we have to substitute t equals 17, which indicates that the length of Corbin's hair is at a maximum at 17 years old. So we substitute that in here, 17 squared minus 2 times 34 times 17 plus 290. This becomes 289 minus 2 times 17 squared plus 290. Recall that I didn't even need to expand 17 squared. I could have just done 17 squared minus 2 times 17 squared, which is negative 17 squared plus 290. Obviously, the numbers were engineered for this specific purpose, because then we get negative 289 plus 290, which results in 1. So therefore, if the bottom evaluates to 1, then we're told that L of 17 is equal to 1 over 1, which gives us 1. Therefore, the maximum length of Corbin's hair must be 1 meter, or alternatively, C. And that is the correct answer. All right, on to question 4. How many asymptotes does Lila of X have? I'm not going to write out the full function definition, but I will write out this part right here. Okay, obviously these are very small numbers, so it implies that there may be some form of factoring, which you can simplify. This becomes x plus 1 squared all over x plus 1 times x plus 3. So we're going to first check for vertical asymptotes and then horizontal asymptotes. So we can obviously cancel the x plus 1 here. So this gives us x plus 1 all over x plus 3. Clearly, x plus 1 is vertical a discontinuity here. So x equals negative 1. If you can visualize the graph, there would be a hole there. And over here, we can have a clear asymptote at x equals negative 3. The graph, the denominator of this function would equal 0. So that is one thing. That is a vertical asymptote, rather. We have one vertical asymptote, and to check for horizontal asymptotes, we see that the degree of the numerator and denominator are both equal. So therefore, we can just take the limit as x approaches infinity. But for those of you who are still not at freeze to limit stage, we can just simply say that the coefficients here, the ratio of the coefficients, is going to determine the end behavior for this function. So this becomes x squared all over x squared. This is 1 over 1. So therefore, there is a horizontal asymptote rather at y equals 1, which necessarily determines that we have two asymptotes in total, which results in answer choice C. All right, on to question 5. All right, we're given that it is someone's birthday, and he's wearing a conical hat with a diameter of 2 centimeters and a height of 3 centimeters. Okay, so visualizing what this looks like. We're told it's a diameter of 2 centimeters, which should not trick us. We're told that this is a diameter, so therefore the radius of this is 1, and the height is 3. We're not given any trickery or any different measurements. We can directly calculate the volume. Recalling that the volume of a cone is 1/3 pi r squared h, we can then say that this is 1/3 pi. This is 1 squared times 3, which is simply just pi. Again, our approximation for pi is 3.14, and rounded to the nearest integer gives us roughly 3. Question 6. It takes 4 thetas, exactly 4 hours, to fail 4 tests. How many hours does it take 1 theta to fail 1 test? Of course, this can just be related just through thinking of the logic. If we have 4 thetas taking 4 hours to fail 4 tests, then reducing any of these measurements by the corresponding proportional amount is not going to change the other ones. So it's still going to take 1 theta, 4 hours to fail 1 test. And of course, time is still occurring at the same rate. So even if we add more thetas and even if we increase the amount of tests, the time elapsed has not changed. Therefore, the correct answer is going to be A. For question 7, it says, how many subsets of a 10-element set are there such that each subset has an even number of elements? Okay, so this one is a bit of casework. So we can either have 0 to 10 to 8 and 4, 6. So again, I'll run through my thought process here a little bit. We can either select a subset with 0 elements, and therefore that must mean we have 10. We can select a subset with 2 elements, and therefore must have 8. We can select a subset with 4 elements, and we must have 6. So it's important that we have all possibilities accounted for. So recall that we can actually just use a difference argument here of saying that there are a total of 2 to the 10th subsets that can be generated from this list, right? 2 to the 11th, because either if he selects an arbitrary element E, it is either in the set or out. So each of these is a binary choice. We could therefore have 2 to the 10th. Well, actually, there are 10 elements. So therefore, we have 2 to the 10th, which is 1024. However, we're told that each subset has to have an even number of elements, and this is going to occur half of the time. Because if we select to have 0 or 2 or 4 or 6 or 8 of the time, this is going to be exactly half of the possibilities that we picked. Again, it's imagining for picking from 1 to 10 and asking it to count how many even numbers. It's going to be exactly half of the total population. So therefore, we have 1024 divided by 2, which results in 512 subsets that are going to have an even number of elements, which leads us to answer D. Question number 8, it says, find the sum of the inradius and circumradius of an equilateral triangle of side length 4s. Okay, so let's write down our formulas here quickly for inradius and circumradius. For the inradius, which we'll denote by little r, the area of the triangle equals the radius times the semiperimeter. And for the circumradius, we are told that the area, we're not told, I'm writing, the area is equal to the product of the side lengths all over 4 times the circumradius. Okay, so let's solve for the area. We're told that the equilateral triangle has side length 4s. Recall that the area of the triangle is therefore going to be s squared root 3 over 4. S is an improper term. We'll say s1. We're told that s1 equals 4s. So 4s squared root 3 over 4 is equal to 16s squared root 3 over 4, which is 4s squared root 3. So we know I now have the area of the triangle, and that can be interpolated to find the area of the radius and the circumradius. So 4s squared root 3 equals r times the semiperimeter. Here is just 4s times 3, because there are 3 side lengths that are identical. all divided by 2, which results in 6s. So r times 6s. Dividing, we divide an s here and divide by 6. So therefore, r in radius is going to be 2 root 3s all over 3. As for our circumradius, we have that the area is 4s squared root 3. This is equal to the product of the side lengths. Each side length is the same, so there is 4s times 4s times 4s, which is 64s cubed all over 4r. Clearly, the 4's cancel here. We're left with 16. The s squared is going to cancel here, so we're left with an s, actually. And therefore, this results in us having 4 root 3 equals 16s over r. Solving for r, we get r is equal to 16s over 4 root 3, which is equivalent to 4s over root 3, which is equal to 4 root 3s over 3. Adding these two together, we then get 6 root 3s over 3, which clearly simplifies to 2 root 3s, which therefore becomes answer choice B, which is correct. Okay, we're told to convert the base 10 decimal 0.625 to base 2. All right. So again, recall what the base expansion of a decimal number means. It means that we're writing this as 6 times 10 to the negative 1 plus 2 times 10 to the negative 2 plus 5 times 10 to the negative 3. And we instead want to interpret this as, a sub 1 times 10 times 2 to the negative 1 plus a sub 2 times 2 to the negative 2, and so on and so forth, for however many parts of the fractional expansion that we need. So clearly here, let's start deducting what we need. So clearly this is greater than 1/2, so we're going to have 1 times 2 to the negative 1. That's going to give us 1/2. We're now left with 0.625 minus 0.5, which gives us 0.125. Clearly, this is less than a fourth, so we're not going to have any decimal, or we're not going to have any bit representing 2 to the negative 2. And actually, coincidentally enough, this is precisely 10 to the negative 3. So we're going to have that bit activated for 10 to the negative 3. This is 1/8, which is 0.125. So therefore, our decimal expansion for this is going to be 0.1, which corresponds to this bit, 0, 1. So 0.101 in base 2, which corresponds to answer B.